Okay, so guys, here's how it goes. Um, yes, everything that I'm going to be training you will be from the syllabus, and will be. I want you to ask me questions. Tell me what to focus on. If there's something that you need me to talk about, make sure you tell me. Right? Are we together? Okay, good. So we have 9 chapters that we have to quickly cover, like in 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 a short space of time. Where I want to do, I want to go to this page. I want to go to. Let me see the page that I want. Okay, this is the page that I want. Here are the 9 chapters, and I want us to look at chapter 9, which is complex numbers, and then we'll talk about the other things. Okay, differentiation, integration, differential equations. Beautiful, beautiful stuff. We'll talk about it, but I'll mention complex numbers a bit and give you the things that you need to have for you to say you're good at complex numbers. Are you ready? I want to talk about some things and we cover some things. And I have videos that I'll share with you that I've made before. You add with this. I'll be making videos for you as well. So I can make videos. You just send me what you need me to make, and then I'll make videos for you, and then we'll be progressing like that. Right? Are we together? Good. So here's how complex numbers works. I want you to focus on when you do a topic, right? When you do a topic, you should focus on the hard parts. Every topic has a major part that you should know. Oh, okay. Differentiation, um, differentiation, integration, um, differential equations. These are going to be one thing. Differentiation and integration, you do them together. They are called calculus, right? And I'll make you master the rules. They are different. Then differential equations is just part of integration, but just 2 things change. And I'm going to show you the 2 things that change to say now we are doing differential equations. But there will be a part of differential equations where you will integrate. So you're going to integrate, but then you're going to add something else. I'll show you. Complex numbers is a completely different thing. So when you do complex numbers, it's linked to nothing. There is no topic that you say to me, sir, I need to make sure I know this topic for paper 3 before I do complex numbers. No, there is no topic that you need to know. It's its own topic, it stands alone. So when you do complex numbers, you do complex numbers and you finish complex numbers. Then you go to something else. So you don't have to know a certain topic for you to be good at complex numbers. Complex numbers are its own. This is its own topic. So let's put it in. Let's see what it's like. Right. Do you guys prefer a whiteboard like this for like watching, or do you prefer a black one? Which one is better, white or black? Okay. With no lines, that's harder for me. I can do it, but then it becomes harder for me to write on it because my I'll be sliding down like this. What if I do dotted like this? This one. Let me show you. This one is okay, or you want it completely plain? Okay, good. So chapter 9. Okay, chapter 9, complex numbers. Chapter 9, complex numbers. So the first thing I want to quickly tell you is I want to quickly teach you is what a complex number is, because that's the first question that everybody has, right? To say, what is a complex number? And then we're going to go into what are the things that you must know for you to answer the past paper questions that we'll do together. Complex numbers, these are a number with 2 parts. So you can just write uh, mm, What is a complex number? Okay? What is a complex number? This is what we are doing in the first part. What is a complex number? So can you write with me to say a complex number is a number or any number that has two parts. A complex number is any number that has two parts. One real part. When we say the real part, we are saying a normal number. A normal number that we can have. Then two is an imaginary part. So a complex number has these two combined. It will have a real part, it will have an imaginary part put together. Then we will say, wow, now we have a complex number. Okay? Anytime you see us have a real part and an imaginary part come together, then we now have a complex number. Okay? Now I want you to write this. There are three types or forms of complex numbers. There are three types of forms of them, these complex numbers. These numbers that have a real part and an imaginary part. The first one is called Cartesian complex number. Okay? It is the Cartesian form of a complex number. This is the first one. The Cartesian form of a complex number. So, if you see me raising my voice and shouting and saying things to you guys, like to say, do you hear me? Make sure you hear me. Stuff like that. I'll be doing it for the shorts, okay? The shorts that I make with the live lesson. Are we together? Ethan, do you hear me? It's nothing wild, okay? Yeah. I'll be making sure you hear the important, because they are important parts. It's like one thing I've mastered by doing school a lot is like any topic, guys, any topic for chem, for bio, for any subject you're doing, when you do a topic, if you want to pass, you should have the skill. It's a skill, guys, of identifying the hard part, because that's the one you'll be asked in the exam. For example, if you're doing chemistry, do you do chem, Ethan? Oh, that's good. Okay. When you're doing, like in chemistry, right? When people are studying, there's this topic on chemical energetics. So, or let's say there's this topic called equilibria. There are parts that come and there are parts that don't come. So, where a person should put their attention and focus and everything is on parts that do come. What is a buffer solution? How do I actually calculate it? How do I calculate a buffer solution? So I don't want you to be people who study and open just the beginning of a topic and then you go to bed and say, I'll continue tomorrow. But hey, man, you didn't do the hard part. You just did the definitions. You are studying the wrong part. You should do the hard part. How does an MRI scan work? How does these things for physics, okay? You should focus on what is the first law of thermodynamics, what is entropy, and what question actually comes from this. Like, what question comes from this topic? So that is when I'm going to put things. There are three forms, and I'll show you why you must know them. So there are three forms. The Cartesian form of a complex number is one which is written like this. Remember that it has an imaginary part and it has a real part. So it can be written like this. 7 plus 4i, for example. This is the rectangular form or Cartesian form, where you have here the real part, then here the imaginary part. And together you have a complex number. you have a complex number. Another form, number 2, is called the trig form. So trigonometric form. For this one, it will be now, you write it like this. You put an R outside. Let me take a different color crayon. You put an R outside, then inside you say cos theta plus I sine theta. Okay? This is obviously the imaginary part, and this is obviously the real part. And together, what you have is complex number. This is also a complex number? Yes. What makes it complex? It has imaginary part with I, then it has the real part without I. Then you do the third one, which is called the exponential form. Exponential form, you'll be having it written like this. R e to the I theta, or to the theta I, doesn't matter. We'll see in examples. Here, when we wanted to write this in notations, we could have said x plus iy or yi. This is how you'd write it. Well, obviously, this is the real part. This is the imaginary part. Here you have the real part. Then here you have the imaginary part. This is the exponential form. Right. Why do we need to know each form? Because there are operations that you do when it comes to this. The first thing I want to teach you is Argand diagram, then the four operations that we do, and then we can go to equations. So let's talk about it. How do you represent complex numbers on a graph? So far, what I've given you is I have given you the forms. I've told you what a complex number is, and I've given you the 3 forms that you find it. It has a real part and it has an imaginary part. Don't let me down. A complex number is any number that has 2 parts. If it doesn't have 2 parts, then it's not complex. Now we go to an Argand diagram. An Argand diagram is simply the graph of complex numbers. This is the graph of complex numbers. I'll teach you what is important from here that you can make a mistake on. But when you do an Argand diagram, here's how it is. Draw this with me. Should call this part 2, where we do Argand diagram, which is how you represent complex numbers. That's basically what Argand diagram is all about. It is about how we represent the complex numbers. How do we show them as a graph? So it's just a graph of complex numbers. That is what they'll be calling an Argand diagram. And there's a question which you get in exams on Argand diagram. And then there's a question on equations. Then there's a question on loci. So I'm going to need to show you all those things, right? So can you put this on your Argand diagram? Real, and then this is the imaginary axis. So when you're representing on your complex number, you're going to have the real axis, and instead of x and y, we have the imaginary and the real. Remember, your complex number is called z. Z just means complex number. It will be in the form x plus iy. This is Cartesian form, which makes us be able to represent it here. Now, when we are representing it here, this value is the one which comes here. It's the real value. You just take it and you put it here. Then the y, you leave the I. You come and put the y value on the other axis to show your imaginary. This is how you represent them. Have you seen? This is what we'll be calling an Argand diagram. So we're going to work from here. Now, when you get an Argand diagram, this is what will help us to change from one notation to another. Because when we get, and I'll tell you why we change. Remember, this is where you are going to have your x, somewhere your x, then you have your y. This, where they meet, this describes your complex number position. You would have told us where this complex number z is located. How much on the real axis, then how much on the imaginary axis. Now we can do a line, put a line that comes from the origin and goes to the complex number. This line, we can now describe it. So complex number, here what we are trying to do, we are trying to tell where z is. We can know where z is by telling the real part. How much do you move on the real axis? So you first move on the real. Then we tell you y, which is how much you move on the imaginary axis. Then you get there. But there's another way which we can do. Instead of telling you x, then how much to move y. We can tell you how much to move straight from the origin, to say, hey, from the origin, move 5, whatever you tell the steps. This is called r, which is the straight distance from the origin to z. But for you to be perfect also, you must tell us at what angle, theta. So you need r and theta. These are the other two things that we can use. Once we have r and we have theta, we can now change to these forms, to trigonometric form and exponential form. We should remove from x and y to r and theta. And r, you are asked in the exam, it is the modulus. It is called the modulus of your complex number. Remember, complex number is called z. So r is the modulus of z, which sometimes you see them say the mod of z. It means the modulus of z. Remember that z is equal to x plus iy or yi. Now, the modulus is going to be found, this r, which we now want, will be found by doing this, x squared plus y squared. This gives us the modulus. This gives us the modulus, the length of z. Then from modulus, we can find also theta. Theta is called the argument. And they'll say find arg z. Mod z, arg z is the argument. It's theta. It means tan inverse of y over x, of imaginary over real. This gives theta. And I want you to make sure calculator is in rad when you punch this. Make sure your calculator is in rad, because you must get theta in rad. You must get theta in rad. So modulus and argument, these are just the other things we can use on a graph, r and theta. And with them now you can be able to represent, to say z will now be re to the I theta. This is exponential form. And you can have it as z is equal to r, then you say cos theta plus I sine theta. This is called trig form. This is called the trig form, the trigonometric form. Are we together? Have you seen this, students? Good. Good. So what we have seen is that we have these three forms, and we have seen how to change It's so important. We've seen how to represent on an Argand diagram, and we have seen how to change. These are important formulas. Hey, you gotta know how to find the modulus, and you gotta know how to find the argument. These are important formulas that you must make sure you know. Very important formulas. All right. So now that I know, you now know how to represent complex numbers on a graph. We are done with graphs. We now want to do some certain things, then we'll see. We want to do part 3, which is the 4 operations. The 4 operations of complex numbers. The 4 operations of complex numbers. How do you do the 4 operations? These 4, which is addition, subtraction, division, and multiplication. The 4 operations of complex numbers. How are they done? How do you add complex numbers? How do you subtract? Let's start with adding, addition of complex numbers. Okay? Let's say you have Z1 being equal to X plus IY. Should we say? Then you have Z2 being equal to A plus IB. Or BI. Doesn't matter. Now, you should know that when you add Z1, okay, Z1, okay, I'll put addition below here because I want to first make sure you write the complex numbers that you have. Then now let's start working with these complex numbers. For addition, we would say Z1 plus Z2 is equal to, what is Z1? X plus IY, and this is adding A plus IB. Now, how do you add? It's so simple. Adding and subtraction, these are so simple. You just add the real parts, then you add the imaginary part separately. So it's X plus A, then plus, here we have this and this. So it will be Y plus B of I. So when you are adding, imaginary adds imaginary. Real adds real. This is for adding. We want to see the 4 operations of the complex numbers. We've seen their graphs. Now we are beginning to start doing the real things now, the tough things. We've seen how to add. Then now we want to see how to subtract. Subtraction of complex numbers. What would we do if we had Z1 minus Z2? It would be X plus IY minus A plus IB. Now we are subtracting. What do? The real subtracts the real. So it is X minus A. Okay? Then plus, you have the imaginary subtracting. So remember to say plus. Then you now will have imaginary subtracting. Y minus B of I. Can you see this? Students? Can you see how to add and subtract? Okay. Now, Ru, are you there? Yes, you can ask. Okay, that's a very good question. Whenever you are subtracting, don't subtract outside. This is important. Do not subtract outside. What I mean is, when we are adding or subtracting, let's do the subtraction. The subtraction sign affects guys when they're affecting each other. I don't want to see a subtraction sign here, because what is subtracting is real is subtracting real. Imaginary is subtracting imaginary. Do you get it? Once you put a subtraction sign outside here, it means you are trying to have real and imaginary subtract each other. Do you get it? So that'll be a problem. Real and imaginary should never add or subtract each other. Okay? Yes. So the subtraction should stay solely inside the brackets. I know it was outside like this, but when you convert it to what it actually means, I know it was outside. But what it actually means is the guys will affect each other. The real will be subtracted by the real in their own bracket. Joined to imaginary y subtracted by the other imaginary b. So this is just a join. Do you understand? Ru? Do you understand, girls? Good. Now, what about dividing? So, what about dividing and multiplying? So, when we now come to dividing and multiplying, we now start to include conjugates. We start to include conjugates. So, I need to make everybody understand this before we talk about dividing and multiplying complex numbers. The biggest question is, sir, what does I represent? I represent square root of -1. This is one of the most important things that you must know. We want to know with examples how you multiply and divide complex numbers in Cartesian form or in rectangular form. And for us to know that, the first thing everybody should know is that I represents root of -1. Not -1, but root of -1. Which means if you ever meet I squared, it is the root of -1 all squared, which is actually now just the root, the -1. So I squared is -1 because I is root of -1. So I squared is the one which will now be -1. So this is very important. Are we together? Students, are we together? Good. So now, if we meet I squared, we are going to remove it and put -1. If we meet I squared. On the other hand, if we have negative in a square root, we are going to remove that negative in the square root and put I. Are we together? Because I is square root of negative. Are we together? So let's go for it. Let's go for it, guys. Let's go for it. I'm counting on you. So what we're going to do is we would say, let's say they give you an example. We are going to say what is now multiplication, part C. And I'll show you the easier way to multiply complex numbers. Multiplication, what is Z1 times Z2? So here what we are teaching you is what you will be using to get to the final answer in an exam question. Exam questions will require you to do a lot of things, but somewhere along the line, you may need to multiply. Somewhere along the line, you may need to add. Somewhere along the line, you may need to divide or subtract. So when you're multiplying, look at it now. When you're multiplying, remember, first one was x plus I, y. Okay, even if you say plus y, I, still fine. If you say I, y, still fine. Multiplying, I'm not yet focusing on that. A plus IB. So here's what happens when you multiply. You have to be fair. You multiply normally like algebra. Okay? Expand. Expand normally like algebra. But what you do know is that if I meet I squared, we should remove it and put negative 1. So x will multiply A. You have x by A plus x will now multiply this. So you have now x multiplying IB or BI plus this one will multiply this. So you now have IY multiplying A plus this one will multiply this. You now have IY multiplying IB. And what you end up having is x times A, AX. X times IB is going to be BX of I. Or if you want to say I, BX. Plus I times this, it is going to be I, AY. Plus this now, which was going to become I squared. Then you have YB. So you will now have I squared YB. Then we can continue. This remains as AX. This remains as IBX. This remains as IAY. But here we now have an I squared, which should become a negative 1. So it will change the sign here. It's negative 1 by YB. Okay, which is negative of YB. Because we have I squared, which we know once we see it, we remove it. So now we have this is a negative 1 by YB. Now the question becomes, what is the final solution here? The final solution will be, you join the real parts. This is real because it has no I. Again, this is now real because it no longer has I. It had I squared, it is gone. So for real, we'll say AX minus YB. These are the real. Plus here, we will have I. Then inside we have BX plus AY. Or we can even put the I outside. This is what we'll be having. This is how we'll get an answer. Have you seen how to add, how to multiply? You just expand, but remember to remove I squared and put negative 1. All right. What about the last one, which is to divide? Maybe let me teach you something. If you multiply, no, I'll teach you later. I don't want to confuse you. I'll teach you later. Let's do division. What is Z1 divided by Z2? X plus YI divided by A plus BI. How do we divide? So the only way to divide two complex numbers is like what we were doing for surds. I'll explain. What it just means is you need to multiply the top and the bottom by the conjugate of the bottom. So this is A plus BI. So we should multiply by A minus BI. Conjugate means you change this plus to make it a negative. Everything else remains the same. So here we have them divided. We now have them divided. So let's see what would happen when we are dividing. We multiply at the top. So x will meet a. You have ax. Okay. X by a. Plus. Here, these, remember, they are multiplying. It's brackets. X times this. So it's going to be minus, actually, x by bi. Plus here, y. We'll multiply this. So it'll be. Then you would have minus of, here you will have yi multiplying bi. This is at the top. At the bottom, what you have is conjugate. Remember, you multiply at the top and at the bottom by the conjugate of the denominator. So this denominator is two conjugates multiplying. What do you get? You just say a by a, you get a squared. Then you say minus, then you square these last terms. So it will be b squared, I squared. Can you see that? I'm teaching you the shortcut of conjugates. It's a big thing. Okay. Let's do step by step. If I have 5 minus 3i, what is the conjugate? 5 plus 3i. Are we agreeing on this? Conjugate means bring the exact same thing, but change the sign between them. Okay? So these two are conjugates. Do you agree with me? Students, do you agree with me that these two are conjugates? Okay. So what we hate in complex numbers when we are dividing is we don't want to see a complex number in the denominator. So maybe I should have used numbers for this to make everything be easy. Z1 is now 4 minus 6i. Z2 is now 2 plus 3i. Now they want us to find Z1 over Z2. In other words, 4 minus 6i divided by 2 plus 3i. Now what we hate is we hate seeing a complex number in the denominator. There's a problem here. We have a complex number in the denominator. So we have a problem, students, that we got to solve. Now, how are we going to solve this problem? We don't want this one in the bottom. We don't want it. So we will multiply. You can put it like this if you want to see. The bottom and the top by the conjugate. So please tell me, what is the conjugate of this denominator which we don't want in this case? What's the conjugate? What is the conjugate of this one? Guys, what's the conjugate of 2 plus 3i? It's 2 minus 3i. Yes. So this is the guy who we will multiply the bottom and the top. This is the only way to divide. Multiply by conjugate. Oh, really? Yes. Now what do you have? You have 2 things multiplying at the top, then 2 things multiply. Because bottom multiplies bottom, top multiplies top. So what you have is you now take this 4 it's now multiplying everything here. So 4 will multiply 2 minus 4 will then multiply 3i. The reason I put the minus is it's here. Then we now take 6, but it's a negative. So negative 6i will multiply the 2. Then negative 6i will multiply negative 6 by 2, which is the first number here. Then you say negative 6i by negative 3i. And you divide everything now. You've done very well. You divide everything by the answer you get when you multiply these two. That's what we want now. The answer you get when you multiply conjugates. So the answer you get when you multiply conjugates, here is how you get it. You just square the first term. So it's 2 squared. Then you put a minus. Then you square the last term. So it'll be negative 3i all squared. So here, what will you end up getting? You end up getting 4 by 2 is 8, minus 4 by 3, that's 12i, minus 6 by 2, that's 12i as well. Then here you have minus times minus, it becomes positive. Can you see this? You say this becomes plus 6 by 3, that's 18. Then I times I is I squared. So you need to practice this part. This part you need to practice if it's the part of expanding. Then now you say divided by 2 squared is 4. Then you say minus of negative 3 all squared becomes positive 9 I squared. Because the I will also be squared. So what will we end up having? This 18i squared is going to be 8 minus 24. Here it becomes 8 minus 24 because there's minus 12 is minus 24. 18i squared becomes negative 1 by 18 because I squared is negative 1. So you can just write it as negative 18. 4 minus 9i squared becomes 4. So here it will be 4 plus 9. Because this negative will become a negative 1 and come in front and change the sign from this. So here it becomes 8 minus 18, that's negative 10. So it's negative 24i. Here, you see the answer? Negative 24i minus 10 divided by 11. This is what you do. Are we together? Which one? 30. What am I saying? How have I lost this? 30. Yeah, good. So this becomes your solution. So we are done. Yeah. Yes, yes, yes. You multiply both. If you multiply one, that means you are breaking maths because you'd be changing the fraction. But for you not to change the fraction, what you do to the top, you gotta do to the bottom. Do you get it? So that's why we multiply the top and the bottom. Ravimba, are we together? Okay. So the four, what did I want to say? The four uh, functions of complex numbers. Are we able to do them? Addition is a function. Subtraction is a function. Multiplying and dividing. If you have a problem here, then this is where you should practice. I'll use some numbers when we are doing multiplication in a question just now. Now let's go to harder thing. This is another section that I'll give you, and we'll do some past papers on it. One of the last ones. This is called equations. How we use, solving equations using complex numbers. Solving equations with complex roots. Solving equations with complex roots. I want to build you up carefully here so that you don't make a mistake. I want to build you up carefully here so you don't make a mistake. Zico, are you there? Yes, negative 8 by 13 things too. So, everybody, I hope everybody can hear me in the live stream as well on chat. Right, now, how do we solve? This is where things become hard. So, this is why I'm training you to say, when you say you don't understand complex numbers, it's not really the background. So when you say, I want to be good at complex numbers, don't just then go and study the background and start spending hours and hours and hours fixing the background. Okay, it's good to know this background. What is a complex number? What is the Argand diagram? What are the forms, modulus and argument, and everything? But then there are going to be major questions. This is what separates people now. Are you able to now do these last two parts? The hard parts of complex numbers that you get asked in exams. First one is how you solve equations that have complex roots. Let's write this, everybody. Write it with me. By the way, complex roots means complex number answers. Remember, a complex number is a type of a number. It's a number that has a real part and an imaginary part. Is this madness, sir? Why would people study complex numbers? What do they help? You wouldn't be having electricity if you didn't have this. Any electrical engineer has to be very good at this. There's no electricity without this. To design circuits in moles and in everything, they use this. So, complex number in equations. Write these statements that I want to give you that are going to be very important for this part which we're now doing. You can never have an odd number of complex roots. Remember, roots are solutions to an equation. So you cannot have an odd number of complex solutions. You can't have 3 complex solutions. That's not maths. The rules say you can't. So you should never go against the rules. Possible number of complex solutions. The possible numbers of complex solutions would be 0, 2, and 4. You can have 0 complex solutions. You can have 2 complex solutions. Or you can have 4 complex solutions in an equation. So remember, though, that when you have a quadratic, then a cubic, because you can have either of these, then a quartic equation. Quadratic equation, you have x to the power of 2. This is, the power 2 is the highest power. This is going to be the highest power you have. You do not have x to the 3. This would be a quadratic equation, e.g. 5x squared minus 9x plus 3. Or even to say 4 minus 2x squared. These are quadratic because there is an x squared and it's the highest power. So these are quadratic. And I want you to know that these have, okay, 2 solutions. 2 solutions. So these are different statements that I'm giving you. I'm not repeating myself. When you're solving an equation, there are 2 things that you'll be remembering as you are solving it. The first thing you must know is, what type of an equation do I have? Now, how many solutions in total can it give me? So if I am solving a quadratic equation, I know that in total, it can give me 2 solutions or 2 roots. Quadratic should always give you 2 solutions or 2 roots. Now, what we then know also is that for complex, on the solutions that you have, isn't for quadratic, total must be 2. If the total must be 2, then that means what options would we have? How many complex solutions can we get in a quadratic equation? Can we get 4 complex solutions in a quadratic equation? No. Why? Because a quadratic equation can only have 2 solutions maximum. Can we get 2 complex solutions in a quadratic equation? Yes, hypothetically. Yes, because you can get 2 complex solutions. Can you get 0 complex solutions and just have 2 in a quadratic equation? Yes. But what you cannot do, you can't have in a quadratic equation, you can't have 1 complex solution. Because quadratic needs to have 2 in total. So if you have 1 complex solution, it means you have 1 complex and 1 real, which is impossible. Complex is always even. Let's go to cubic so that you can understand why I really am saying this. Cubic is when you have x to the 3 as your highest power. Okay, I need to make sure you are understanding. Now, how many solutions in total can we get here? Total 3 solutions. For cubic, you can get in total 3. Now, how many complex solutions can you get for cubic? 0 or 2 complex. But total, we must have 3. So when we get 2 complex solutions, I then want to see you looking for the third solution, which will be a real one. Are we together? Because there must be a total of 3. But you can't have 3 complex ones. Are we together, students? Good. So we're going to reason together, don't worry. To say, guys, how many solutions should we have in total? 3. How many complex can we have? 0, or we can have 2. What about for quatic now? You now have x to the power of 4 as your highest power. It should have in total 4 solutions. 4 solutions in total, because the highest power is x to the 4. Which means you can have 0 or 2 or 4 complex solutions. Because we have 4 answers in total. And we know that complex takes even numbers. So we can get 0 or 2 or 4. So if they ask you, here's what they will ask you. What are the possible situations for a quatic equation? You must tell them, I can have 0 complex, which means it will be 4 real solutions. When we just say real solutions, we mean real numbers. The solutions will be real numbers, like 2 or 4 or root of 9 or root of something. Or you can have 2 real solutions and 2 complex solutions, because you must have 4 solutions in total. Or you can have 4 complex solutions in a quatic equation and 0 real. So this will be your situations. I will write it, but can people just write that? Quatic, I should have 4 in total, and my complex can be 0 or 2 or 4. For cubic, I should have 3 in total, and my complex should be 0 or 2. Write this down. Have you written this down? Okay. Okay. So guys, if you ever get a cubic equation, z to the power 3, then they give you one solution, z to the power 3 plus what. Then they give you one solution, 4 minus 3i is a solution or a root. Students, you should not let me down. You know that you can't have one solution, because that means this is only one complex solution. You know that for complex I can have 0 or 2 or 4. So in this cubic I can have either 0 or 2. I can't have 1. So if they give me this one, I should automatically find the second one. And how do you find the second one? By making conjugates. So 4 minus 3i is a root. Then 4 plus 3i, which is the conjugate, is automatically the second solution. So if 1 is a root, the second solution, or second root. If 1 is a root, then its conjugate is automatically going to be the second root. What I now need to do is questions with you guys. I'm going to have to do questions with you guys. But what I have given you is background. So, of course, with questions, there is practice. There is practice where we'll be using some of these things that we have talked about. I'm going to show you how. We'll be just solving them normally, but we'll be using the idea that we'll be, of course, when we get one solution, we'll get the second one. After getting the second one, we now start to look for other solutions, using this information that I've given you here. Right? This is it. I'm going to give you a small break, then meet you to now do the past paper questions where we'll be using Argand diagrams, modulus, argument, and equations. Get a small break and come back. We do past paper questions on complex numbers, right? What time do I meet you guys? You guys are not boarders, right? You guys are not boarders.